With the greatest name of Allah, who is the most merciful and beneficent. Today, we are going to present our final presentation. Our final presentation is on the topic of design of solar-assisted desiccant cooling system. Me, Abdul Ghafoor, my group mate, Muhammad Irfan. We worked under the supervision of engineer Shakil Jiskani, and our co-supervisor is engineer Qasir Ali. This is the outline which we are going to follow. Discuss about the problem statements, introduction, literature review, aims and objectives, journal flow, desiccant material, components required, budget, result, final prototype, conclusion, and then references. These are the problem statements which motivates us to make our project. The first is shortage of electricity. As in case of Pakistan, we can say that it is well defined. And the next is global warming. And we know that global warming is also the big issue in the world. The third is hot climate and high temperature. And the last is very expensive cooling system available in the world. This is the introduction of our project. It is non-conventional way to make the cooling system. This cooling system uses excess summer heat from the solar panel to drive the desiccant cooling system. There is two technologies involved. First is called Peltier cooling and the other is called desiccant drying. Desiccant drying basically is a material which absorbs moisture from the air. And these technologies convert primary energy. Primary energy means the energy taken from the sun into heating or cooling purpose. These are some aims and objectives of our project. First aim is conservation of electrical power. By this project, we will conserve the electricity because almost 40% of the whole power consumed in a building is used for the cooling purpose. The next purpose is contribution in the reduction of global warming. Doing this, we will contribute in the reduction in the global warming because most of the electrical power is produced in the Pakistan by thermal combustion of fossil fuels. By doing this, the global warming is increased. And the third one is cost-efficient cooling system. It will also reduce the overall cost of the cooling system because main role in the cooling system is of electricity. So cost will be reduced. And the last is commercialization. Our main aim is to make a product which is usable for the purpose for the person of every class. And there is the literature review related to our project. In the first, the study is made about the desiccant cooling system and it is tested under the 3 different climates. The first climate is related to oceanic, the second is humid and subtropical, and the last one is hot, some semi-arid climates. And the second paper is about the desiccant cooling system and its types. It is written that there is 3 types of the desiccant cooling system. First is known as energy recovery. Second is solar hybrid desiccant cooling system. And the last is solar absorption cooling system. And in the third paper, the study is made about the desiccant cooling system and the results are taken on the software. And 5 months results are analyzed and the conclusion is shown in the simulations. And in this paper, In the fourth paper, the research is conducted about the high latent loads of the buildings. And it is proved that by doing desiccant cooling system, it might save up to 60% of energy when compared to vapor compression air conditioning systems. And in the fifth paper, the study is about hybrid desiccant cooling system. Hybrid means the cooling system is used for both air cooling and the water cooling. And in the last paper, the study is conducted about the desiccant materials, its properties, its uses, and its availabilities. And this is the BTU calculations. BTU is known as British Thermal Unit. BTU contains the heat from the person, heat from the area of the room, plus heat from the window of the room, plus heat from the doors of the room, and also plus heat from the load in the room. And it is concluded that 1 ton of cooling is equal to 12,000 BTUs. And this is the calculation of the room. If you want to make the system for a room of area is given here, 16 by 15. So first we should calculate the BTUs of the room. So these are BTUs of the rooms, and when we convert it into tons, so we can see that 0.81 ton is required to cool this room. And units of silica gel are required for the room is 388, and the kgs of the silica gel required is 10.88 kg is required to cool this area of the room. This is calculation for the prototype. We made a prototype, and its length is 3, its width is 3, and the total area is 9. So total BTU required is 2771, and BTU when we convert into tons, so 0.02 ton are required, and units of silica gel required is about 15, and the silica in kilogram is 0.4. It means that half kg is required to cool this prototype. And this is the famous desiccant materials which can be used as a cooling system in the cooling system. The first one is calcium chloride. It has some side effects. It's high cost. It is used as a liquid and solution. It is not easily available. And the second one is calcium sulfate. It has side effect for health and the redness of eye issues. And the third one is silica gel. It has also some side effect. It is not breakable if eaten. And the fourth one is sodium chlorate. Solution is necessary to use the sodium chlorate, and it has harmful for both human and environment. And the last one is sucrose. It has high price, low efficiency, not reusable. Why silica gel SiO2 we choose for our cooling purpose? It has stronger absorption for humidity, perfect desiccant of high capacity, not flammable, reused by regenerating, heating. The gel will stave off absorption. It can absorb up to 40% of its own weight. Shelf life is indefinite of the silica gel. It is inert and will not corrode or disrupt the material. It also can be conventionally packed, and it is available in many sizes for the various applications. This is the general project flow. The outdoor air is entered from here and it passes from the silica gel, and silica gel is absorb the water molecules from the air, and the dry air is passes sent again, and the dry air is passes from the heat sink, and heat sink recovers some heat and it cool down that air, and the cool air is then again passes from the Peltier cooler, and Peltier cooler tries to reduce the air up to the human comfort level. Then this air, with the help of PVC pipe, is entered into again a heat recovery wheel, where the temperature is again slowed down, and then the chill air is entered into the room, and on the other side the hot air is exhausted with the help of exhaust fan. These are some main components which we required to make our project. The first one is Peltier cooling. It is used for the small cooling purpose. And the next is DST22 sensor. It is used to measure the temperature of inside the box. This is the silica gel, which is used as the desiccant material in our project. It absorbs water molecules from the air. This is the fan. It helps us to recover hot air from the room. This is the chipboard box which we use for the testing purpose. Its length is 3 feet, its height is 3 feet, and width is 2 feet. And this is the solar plate, 15 watt and 12 volt. We use to supply the exhaust fan and the Peltier kit. This is the total budget of our project, which we require to make our project. And we know that the total budget is about 14,000. This is the basic method to take the results. This is the outside temperature, and this is the temperature after some time. And this is the humidity. These LCDs are showing the humidity value and the temperature value. These are results which we are taken day by day. The first day result is shown here. This table shows that we start experiment at 1 o'clock, and time the outside temperature is 42.5 and inside temperature inside temperature 42, and after 15 minutes the outside temperature is 42 and inside is 34.9. After 30 minutes the outside temperature is 42 and inside is 34. After 25 minutes the outside temperature is 42 and inside is 32 degree. And after half hours the outside temperature is 42 and the inside is 31 degree centigrade. And this is the graph which is showing this data. In the y-axis the temperature is shown in centigrade, and in the x-axis the time is shown in the minutes. And in the red columns the inside temperature is shown, and we can see that the temperature is decreasing with the time. This is the second day result, 19/3/2022. And the experiment is started at 11 o'clock, and the outside temperature at that time is 39.9 and the inside is 39, and after half hour the outside temperature is 39.5 and inside is 31.4. And this is the same graph of that table, which is showing the temperature with respect to time. X-axis is showing the temperature and x-axis is showing the time. And same the third day result. Third day results, the experiment is started at 2 o'clock and the outside temperature was 42 and inside is 42. And after 45 minutes, the outside temperature remains same, 42, and the inside will decrease up to 25.10. So, and this is the result of this table. Outside the graph is showing and the temperature is on the y-axis and the x-axis time is given. So we can see that the temperature is decreasing with the time. This is the fourth day result. Same results are showing. And then fifth day results. And the last day results means 6th day result. We take this result on 1 April 2022. So this is showing that the experiment is started at 1 o'clock and the outside temperature at that time was 43 and inside was 42. And after 45 minutes, the outside temperature remains same, 43, and inside decreased up to 24.9. And this is the same graph of this data. And on the y-axis, time is shown, and on the x-axis, temperature is shown. So we can see that the yellow columns are showing the inside temperature, and we can see that with respect to time, it is decreasing. This is our final prototype. Here, this is the 3x3 box, and this is LCD, which is showing the temperature of the box, and this is PVC pipe, and here silica gel is used, and at this area, the exhaust fan is put here, and this is the Arduino and one plate, solar plate. So this is the conclusion and recommendation of our project. It concludes that the project is made by using silica gel as desiccant and Peltier device to cool a 3x3 box. We test the project in different times of a day and results are shown above. Satisfactory cooling is obtained. Almost 18 to 20 degrees centigrade is decreasing within 45 minutes. We are achieving about 25 degrees centigrade within 45 minutes, and we can say that it is a human comfort level. And these are some recommendations for future work. First recommendation, we will recommend that try to use other technologies for small cooling. For example, desiccant evaporative cooler can be used instead of Peltier cooling system. And the next is try to use either desiccant cooling system such as calcium chloride, calcium phosphate instead of silica gel. And the last is try to reuse desiccant materials by reheating at 40 degrees centigrade. I hope it will give good results. These are some references which helps us to make this project. Thank you. In the coming